I want to start today with a document that felt like it absolutely shouldn't work. It's this stack of papers that combines advanced graph theory, quantum physics, ancient linguistics, and, well, artificial intelligence. And it starts with an acronym that usually makes people run for the hills.
Oh, I know exactly which one you mean. G.O.D.
G.O.D.
Yeah.
And, usually when you see that in a physics paper or some technical analysis, you assume you've accidentally downloaded a theology sermon or, I don't know, some kind of New Age manifesto.
Mm-hmm.
But looking at the math in this, the actual scaling laws and geometric proofs, this is definitely not a sermon.
No, it's not. It's a theory of everything framework. And look, I know that phrase gets thrown around a lot, usually by people trying to sell you crystals, but this one is distinct because of what that acronym actually stands for. It's not a deity. It stands for geometric object dilation.
Geometric object dilation. So literally, we are talking about the expansion of shapes.
Essentially, yes. The mission of this source material is to propose a single organizing principle for reality. The premise is fascinatingly simple. What if the rule that organizes a hydrogen atom is the exact same rule that organizes a galaxy, a biological cell, and even the way you think?
Okay, that is a massive claim, because usually physics is a house divided, right?
Yeah.
We have quantum mechanics for all the tiny stuff, which is chaotic, probabilistic, just weird.
They're weird.
And then general relativity for the huge stuff like stars and gravity. And famously, those two math systems hate each other. They just don't mesh.
They really don't. They break down the second you try to combine them.
Yeah.
And this source suggests the reason they don't get along is that we've been looking at them as two different things rather than the same process happening at two drastically different scales.
So today, we are going to explore a universe where there's no external architect building things piece by piece. Instead, there's an internal rule set. We're going to talk about why atoms might actually be galaxies, why gravity is so deceptively weak, and this part I'm really keen to get to, how the Hebrew name for God might actually be a formula for physics.
It sounds wild, I know, but when you break it down, it's surprisingly logical.
All right, let's start with the basics. Unpack that acronym for us. Geometric object dilation. It sounds a bit like a sci-fi instruction manual. What are we actually talking about here?
So if you break it down word by word, geometric refers to the structure, the relationships between points.
Yep.
Object is just any stable configuration of that geometry. And dilation is the movement expanding or contracting across scale.
So it's shapes getting bigger or smaller.
But specifically, it's about relational geometry transforming over scale. And the source is very specific about the God definition here. It explicitly states, God equals the rule of organization itself, not an agent. It actually aligns pretty closely with the philosopher Spinoza's idea of deus naturae, God, or nature. The idea is that the rule set isn't sitting outside the universe pulling the strings.
Pulling the strings is inside the system.
Exactly. That distinction is so crucial. It's not a guy with a beard on a cloud. It's the source code running in the background.
Yeah.
The document actually uses the phrase, "we all are God," which sounds provocative, but it clarifies immediately. It doesn't mean you or I can snap our fingers and create a sandwich. It means the organizing principle that structures the cosmos is instantiated locally in every subsystem, including you.
So if this rule is inside everything, we should be able to see the pattern everywhere. If I look at, I don't know, a rock, a tree, and a piece of software, where is this geometric object dilation?
You look for the behavior of the structure. The pattern involves four main things. You have local rules, iterative expansion, self-similarity across scales like fractals and boundary formation.
Okay.
The source gives these great examples to ground it. Let's start with the atom.
All right. Electrons orbiting a nucleus. Standard high school physics model.
Well, in this framework, that's wave function geometry. It's a probability cloud constrained by geometry. Now, scale that up. Look at a crystal.
Okay.
That is lattice dilation. It's the same geometric stacking rule, just repeated. It's a grid getting bigger.
Right. It just keeps going.
Exactly. Then look at biology. Morphogenesis, how a cell divides and becomes an organ. That's geometric expansion constrained by chemical signals, even cities. The source points out that the way a city grows infrastructural scaling follows the same mathematical expansion rules.
Wow. So that implies that reality isn't really made of things in the way we think of them. Like a Lego brick that's a solid object. It's made of relationships that just keep repeating.
That is the key takeaway. Reality evolves by the recursive transformation of relational geometry. A thing, a chair, a star, an electron is just a frozen relationship. It's a stable geometric configuration that persists for a moment.
That actually makes the universe sound, well, The source uses a funny word for it. It calls the universe boring.
I laughed at that part too. It says the universe is boring because it is incredibly repetitious. It's not creative in the sense of constantly inventing new rules. It's iterative. It uses a very, very small set of organizational moves and just repeats them forever.
Once you have dilation plus constraint plus conservation, you get the same zoo forever.
Yeah,
That's the quote, right?
that's the one. It implies that complexity doesn't come from complex rules. It comes from simple rules applied billions and billions of times over. And this leads us to the biggest and probably most controversial comparison in the document.
Oh, yes.
The structural identity between atoms and galaxies.
This is where I really need you to walk me through the math here. Because on the surface, this sounds like a stoned college student theory. Dude, what if an atom is just a tiny solar system? But physicists usually hate that comparison because quantum mechanics just doesn't look like orbital mechanics. They do. But this source brings hard numbers to it. The intuition is that atoms and galaxies are different scale solutions to the same geometric constraints. They aren't just visually similar, they are structurally homologous.
So homologous how?
The source posits that electrons are structurally similar to globular clusters, those dense groups of stars, and that atoms are therefore similar to galaxies.
But the size difference is just incomprehensible. How do you bridge that kind of gap mathematically without just, waving your hands?
It is massive, but it's calculable. The source presents a very specific scaling argument. It calculates a scale separation factor between roughly 10 to the 65th and 10 to the 69th.
Okay, let's pause on that number. 10 to the 65th. That is a 1 followed by 65 zeros. It's a number so big it doesn't really mean anything to my human brain.
Let's ground it. Let's do the math the source suggests. Take the mass of a hydrogen atom, it's tiny, about 1.67 times 10 to the negative 27th kilograms.
A speck of nothing. A speck of nothing. Now, multiply that tiny speck by this scaling factor of 10 to the 65th.
So we're scaling the atom up by 65 orders of magnitude.
Exactly. And when you do that multiplication, you get roughly 1.67 times 10 to the 38th kilograms. Now, if you look at astronomical charts, that mass puts you right in the range of a dwarf galaxy.
That is disturbingly precise. So, mathematically, a dwarf galaxy is just a hydrogen atom scaled way, way up.
In terms of its mass and its structural dominance, yes. The implication is that both atom and dwarf galaxies act as the dominant structural fillers of the universe at their respective scales. They are the same geometric solution, just instantiated at different magnitudes.
That completely changes the mental image of the cosmos. It implies that if you zoomed out far enough, a galaxy might just look like a particle in a much, much larger medium.
And conversely, if you zoomed in enough, the particle looks like a galaxy. This concept is called scale invariance, and this scale invariance helps solve one of the biggest headaches in physics.
The gravity problem.
The gravity problem.
Right, gravity. We mentioned this earlier. It's the force that keeps planets in orbit, yet it's somehow incredibly weak compared to the other forces. I mean, I can pick up a paperclip with a tiny fridge magnet, and that tiny magnet is defeating the gravitational pull of the entire Earth. It just makes no sense.
Exactly, and physicists have struggled with this for a century. Why is gravity so weak? This source argues it's not weak, it's just coarse-grained.
Coarse-grained. You have to explain that metaphor, because usually when I think of gravity, I think of a smooth curve in space-time, not something grainy.
Well, first, we have to clarify, this framework isn't saying Maxwell's equations for electromagnetism or quantum mechanics are wrong. It's saying they are local descriptions. They work perfectly at their specific scale.
So you can't compare apples to oranges without a conversion rate.
Right. Think of it in terms of resolution. Electromagnetism operates on short-range, high-resolution geometry. It's very precise, very local. It's like looking at a 4K image where you can see every single pixel.
Okay, I'm with you. And gravity?
Gravity operates on long-range, low-resolution geometry. It propagates coherence across far more scale transitions. The source estimates gravity works across roughly 10 to the minus 35 scale transitions, while electromagnetism is around 10 to the minus 18.
So gravity is like looking at the same picture, but from a mile away. You don't see the pixels, you just see the big blurry shapes.
Exactly. Because gravity is integrating effects across such a massive range of scales, it's summing up the behavior of trillions of interactions. It appears locally as a weaker force. It's an integrative effect.
So it's not that gravity is a wimpy force, it's that It's the sum total of this huge low-res network, which makes it feel different from the snappy high-res interaction of a magnet.
Correct. And it fits with advanced physics concepts like emergent gravity or entropic gravity. Gravity isn't some fundamental weak force. It's a large-scale geometric side effect of the universe.
It's organizing itself.
Exactly. It is the sound of the entire crowd, whereas electromagnetism is the voice of one person screaming right in your ear.
This idea of geometry being the root of everything, it really permeates the source's take on matter itself. It talks about programmable matter. Now, usually when I hear that, I think of nanobots in a sci-fi movie, little robots swarming around to build a chair.
Yeah, that's the common image.
But the source says we don't need nanobots.
No, because matter is already programmable. The definition of programmable here is pretty simple. Is the behavior rule governed? Is it context dependent? And is it sensitive to information?
Well, yes. Chemistry is basically rule-governed behavior. You mix this with that, and you get a reaction based on the rules of valence electrons.
Exactly. And DNA is literally executable code. It's a string of instructions that tells matter how to build a protein. Protein folding is a computation. It's geometry solving a puzzle to find the most stable shape.
But usually when we think of programmable, we imply a programmer, human writing code to make the matter do something.
And the source flips that agency, and this is a bit humbling. It says humans are not the controllers of programmable matter. We are expressions of matter executing its own code at a very high complexity.
That makes me feel like a very sophisticated NPC and non-playable character in a video game. I think I have free will, but really I'm just executing the hungry script or the sleepy script.
In a way, yes. The framework views reality as a network. Reality equals networks of relations. Geometry is just frozen relationships, stabilized connections. And dynamics, or change, is the dilation and contraction of those relationships.
So if I'm just matter executing code, where does consciousness fit in? Is there any room for me in this geometric web?
The definition here is fascinating and surprisingly robust. It defines conscious systems as localized regions where the network models and then modifies its own structure.
Self-awareness is the network looking at itself in a mirror.
And editing itself. It's where the programmable part becomes recursive. We are the part of the geometry that has become complex enough to map the geometry. We aren't separate from the code. We are the code rewriting itself in real time.
Speaking of rewriting code and ancient symbols, this brings us to what I think is the most surprising left turn in the source material. It goes from high-level physics directly into linguistics and ancient text, specifically the Hebrew name of God, YHWH.
I was expecting this to be the part where the logic just fell apart, to be honest. But the source treats it very structurally. It's not preaching religious dogma. It's making a linguistic observation.
Right.
It maps the 4 letters of the tetragrammaton Yod, hey, to the stages of this geometric dilation framework.
So walk us through that mapping. How does an ancient name map to a theory of physics?
It starts with Yod. In this framework, Yod represents the point, or geometry as a seed, the starting singularity.
Okay, so point zero. The Big Bang, or it's just the start of a thought.
Then you get
hey.
This represents geometry expanded structure or space. The point dilates into a dimension.
Point becomes space. Got it.
Then wow. This represents dynamics change, traversal, connection. It's the movement within that space. And finally, the final hey.
It repeats the hey.
Yes, and that repetition is crucial. It represents information and scale, the constraint made visible. It's the structure stabilizing at a new level. The source argues this creates a self-referential loop, not a linear line. It goes from seed to structure to change and back to structure, but at a new scale.
It's a syntax for being.
Exactly. It encodes how existence keeps happening. It's a loop that cannot collapse into a single thing. And that aligns perfectly with the G.O.D. framework. Reality is a recursive process of expansion and constraint.
It's amazing how these patterns seem to echo. Whether you're looking at ancient texts trying to describe the infinite or advanced graph theory trying to describe the universe, you kind of end up with the same recursive loop.
And that loop brings us to the future. Because if you understand the loop, you can navigate it. And that connects us to artificial intelligence.
Right. The source mentions that our current approach to AI might be missing the point. We are obsessed with training bigger and bigger models, but is that real intelligence?
The source argues no. If reality is a geometric network, then intelligence isn't just magic or text prediction, it's navigation. The source proposes a model of AGI, artificial general intelligence, that is based on spatial graph traversal.
How is that different from what we have now? I mean, we have large language models that are incredibly smart. They predict the next word based on billions of parameters.
But they're essentially guessing based on probability. Current AI works on parameter optimization training on huge datasets to guess the right answer. This source suggests real intelligence is about understanding the topology of the graph of reality.
And this relates to the hallucination problem we see in AI, right?
Mhm.
Where a chatbot just makes up a fact that sounds true but is totally wrong.
Precisely. The source defines hallucination very specifically, extrapolating outside reachable graph states. Basically, the AI jumps to a node in the network that doesn't actually connect to reality. It breaks the geometry.
So in a spatial graph traversal model, you can't hallucinate because you can only travel along existing valid paths.
That's the idea. True intelligence is just knowing how to get from point A to point B in the complex network of truth without falling off the map. Intelligence equals navigation of structure. If you can map the geometry, you can predict the outcome without guessing.
I want to circle back to the scale invariance for a moment.
Yeah.
Because the source offers a thought experiment that is literally mind-bending. It involves a spaceship. And I think this visualizes the theory better than anything else.
Ah, the scaling thought experiment. This is my favorite part for pure visualization.
So the scenario is, I'm sitting in the spaceship, and somehow I have a dial that lets me scale myself and the ship down past the cellular level, down to the atomic level.
Right. And the intuitive assumption based on our standard model of physics is that you would shrink down and see mostly empty space, maybe a nucleus far away, some electrons whizzing by like ghosts, a void.
But the source says no.
The source says you wouldn't enter a void. You would arrive inside a galaxy.
Because of that scale invariance, the atom is a galaxy, just small.
Exactly. As you shrink, your resolution changes. Those probability clouds of electrons, they would resolve into calculable orbits. They would look like solar systems or star clusters. You wouldn't see quantum weirdness. You would see classical mechanics at a microscale.
But wait, if I'm that tiny, wouldn't time feel different? If I'm on an electron looking at the nucleus, am I seeing it move in slow motion?
This is the kicker: time dilation. If you scale a galaxy down to the size of an atom, the frequency of events scales up.
Frequency scales up, meaning things happen faster.
Much faster. Think about it. If you keep the speed of light constant, but you drastically shrink the distance you have to travel to complete an orbit, you complete a lap much, much quicker.
So if I am that tiny observer, the electron isn't a blur to me.
No. To you, it's a planet moving normally. But to an observer back up at our normal size, that planet is completing billions of orbits a second. It becomes a blur. It becomes a cloud.
So the smallest things seem unpredictable to us, not because they are magic, but because of their sheer speed relative to us.
That's the claim. Time accelerates as you shrink. If we look at an atom, we are watching billions of years of its history unfold in a nanosecond of our time.
That makes me dizzy. It implies that if there were civilizations on an electron tiny little micro-societies, their rise and fall, their entire history, would happen so fast we wouldn't even notice.
It would be a momentary flicker, a quantum fluctuation. And conversely, to a massive observer, someone to whom our galaxy is just an atom, our entire lives, the history of the human species, would be a split-second vibration.
Wow. We are the subatomic particles for a giant universe, and the giants to a subatomic universe.
It changes your perspective on space, too. We usually think of space as empty, but in this framework, at each scale, stabilized structures act as the space for the next finer scale.
Like how a galaxy is the space for stars.
And we are the space for sub-biological processes. We are the stable background environment for the cells and molecules inside us.
It's Russian nesting dolls all the way down.
And all the way up, it's a fractal universe.
This has been a heavy, but in a good way. It's one of those deep dives that makes you look at the wall or your hand or the stars and see them as the same thing.
That's the goal of a unified theory, isn't it? To stop seeing parts and start seeing the whole.
So, to recap our mission today, we've covered G.O.D as a geometric rule of expansion, not a deity. We've equated atoms to galaxies using that 10 to the 65th scaling factor, a calculation I'm definitely going to try and explain at parties. We solved the weakness of gravity by calling it low resolution and reimagined ourselves as programmable matter in a self-editing network.
And we learned that if we shrink down, we don't disappear into a void. We just join a faster, smaller galaxy.
Here's the final thought I want to leave our listener with today. It's something the source hinted at but didn't explicitly say. If we are the large-scale structures for the atomic world, and our lifetimes are just nanoseconds to a larger observer, are the erratic movements of quantum particles just civilized solar systems moving at speeds we simply can't comprehend.
It really makes you wonder if randomness is just intelligence moving too fast for us to see.
Exactly. Maybe the universe isn't boring after all. Maybe it's just incredibly busy. Thanks for listening to The Deep Dive. Look at the world a little differently today.
See you in the next scale.